I got a new toy in. It is a Fluke digital oscilloscope. Here we have the model 199 X-ray, borrowed from my good friends in the X-ray department. They've agreed to let me have this device over the weekend in order to view the spectrums on my Rife devices. This particular digital oscilloscope has a spectrum analyzer function built in. It's a really great piece, and let's take a few minutes to watch it work, and we'll get used to looking at the screen before we actually look at a Rife machine, and that way we'll understand better what we're looking at. I'm going to hook some power up to it. Hook some signal up to it. Turn it on. Okay, we see two square waves. What I have hooked up to it is two frequency generators. On one side we have the Model 377 ICO signal generator. We're going to use this because this is what Vern Thompson used back in the day. So we'll look at the spectrum coming off of that, and we'll compare that to a more modern frequency generator, namely the ProGen 2. Okay, both of these are outputting a square wave. You'll see the top trace in red is locked in, and the bottom trace in blue is drifting. The top trace is the ICO square wave, and the bottom trace is the ProGen 2 square wave. The triggering is actually set on the top trace. That's why the top trace is locked in. Both of these signal generators are set on 10,000 hertz square wave. Being that they're both set at the same frequency, the triggering should actually lock them both in. Somehow it's not. If I select the triggering mode, you can see the auto triggering is set to channel A, and channel A is locked in. If I select channel B, all of a sudden channel B stops and is locked in, and channel A drifts. Okay. Now, just for the record here, I said that both of my generators were set to 10,000 hertz. If we look at the actual gauge on the ICO model, 10,000 hertz is found at a gauge setting of about 12,000 hertz. The needle's pointing to somewhere around 12,000 hertz, but I actually dialed in an exact 10,000 hertz frequency at this setting. And so, my point is this old ICO generator has drifted out of calibration, and it makes me wonder if any of the old Rife frequency numbers that we're taking off of the actual gauges of the equipment are correct. I wonder about this. Of course, the modern generator is digitally controlled, and here's your scope waveforms. Let's look at a spectrum of these waveforms. On this particular device, if I press the scope button, I get a selection block on the right here that says waveform options. So we're going to select that. In the waveform options block, you can see this third block over, we're in normal mode, but the third selection down is called mathematics. And if I scroll down, let's see, I want to scroll over to this selection. And then if I scroll down to mathematics and select mathematics, we get another screen that comes up, and it says function, and this spectrum analyzer shows up at that point. So I'm going to select spectrum. And when I did that, the spectrum analyzer showed up in the background. It's set on auto, which is a pretty good setting. It pretty much finds its waveform on auto. I'm going to get this menu out of there. What we're looking at now is, if we look at the top, it says channel A. Channel A is connected to the ICO 377. The ICO 377 is set on square wave at 10,000 hertz. Now we come back to our spectrum analyzer, and we can see that 10,000 hertz on the graph appears here, and everything before 10,000 hertz can be seen down to 1,000 hertz. And you'll notice there's no signal there. All of our harmonics are appearing on the additive side. And what we're seeing too is on this particular spectrum analyzer, we're actually seeing even harmonics and odd harmonics. Now, if I can remind you, the frequency generator is set on square wave, but somehow we're not seeing only odd harmonics. This signal, well, this is your fundamental here, and that's the largest signal amplitude. The next one off to the right is a smaller signal amplitude, and that is 20,000 hertz. The next one is actually a larger signal amplitude, and that's 30,000 hertz. So the odd harmonic is actually taller in amplitude than the even harmonics. But at the same time, the even harmonics are still present. So we have 10,000 hertz, 20,000 hertz, 30,000 hertz, 40,000 hertz is back lower. That once again, the even harmonic is lower in amplitude. And then at 50,000 hertz, the second odd harmonic, it's higher in amplitude. So it's kind of strange that when we switch the ICO 377 generator to square wave, that the even harmonics are still present. Let's compare that to the ProGen 2. Now, as far as our ProGen 2, we have that set at 10,000 hertz, and we're outputting a square wave. Let's switch our spectrum analyzer to view channel B. Input B, turn it on,